Hey there, and welcome to this special edition of Digital Dimension. Today's video is a little different. It's a complete compilation of our three-part series on loops in Python. So whether you're new to loops or just looking for a detailed refresher, you're in the right place. We're going to cover everything from the basics of for loop and while loops to practical examples, advanced techniques, and even some common pitfalls to avoid. Now, let's dive right into it. Imagine having a repetitive task like sending out a bunch of invitations. Wouldn't it be nice if you could automate that? That is where loops come in. Loops in Python allow you to repeat a block of code multiple times without having to write it out each time. We'll be exploring two types of loops. For loops, which are perfect for when you know exactly how many times you need to repeat something, and while loops, which keep going as long as a condition is true. By the end of this video, you'll be able to automate repetitive tasks in your code, making your programs more efficient and powerful. Last time, we saw how if statements could help us make decisions based on conditions. But what if you need to repeat an action for each item in a sequence? That's where for loops come in. To start, let's use something simple like a string. Imagine you want to look at each letter in a word or a sentence. A for loop can help you do that efficiently. Here's an example where we iterate over the word Python and print each letter on a new line. Notice how the loop goes through each character in the string, doing the work with just a few lines of code. We can even use string methods. Do you remember those? For example, we can use upper to make the letters that come out of our for loop uppercase. This is a great way to combine what we've learned about strings with the power of loops to manipulate and work with text in a more dynamic way. Here's the code example for your script. Just like how we structure conditions with if, for loops follow a clear, logical pattern that makes repetitive tasks easy and straightforward. And don't forget to indent. Are you starting to understand what a for loop does? It goes over every letter in a string, in this example, but it can do much more. Sometimes you may need to repeat an action a specific number of times, and this is where range comes in handy. The range function generates a sequence of numbers which we can use in a for loop. Let's take a look at a practical example, printing something a certain number of times. Imagine you want to print a word like party several times. You can use a for loop along with the range function to do this. In this case, range 5 generates a sequence of numbers from 0 to 4. The loop will run 5 times, once for each number in that sequence, and it will print party 5 times. Try it out and see what happens. Let's quickly remind ourselves about something we discussed before, how programming languages like Python often start counting from 0 instead of 1, so when you use range 5, the sequence starts at 0 and ends at 4, even though we think of it as counting 5 times. This is an important concept to keep in mind, as it's common in many programming languages. Let's break down the range function. It can take up to 3 arguments. First, we have start, which is the number where the sequence begins. It is optional, and if it's left empty, it defaults to 0. Stop, which is the number where the sequence ends. Attention, because it doesn't include this number. And step, which is the difference between each number in the sequence. It is optional, and if it's left empty, it defaults to 1. For now, we're only using one argument, 5, which tells the loop to repeat 5 times. Each time the for loop runs, it executes the print function and prints party. Let's take a look at a more detailed example by creating a countdown. This is a great way to explore how we can use more arguments with the range function. By using range 10, 0 minus 1, we can set our loop to count down from 10 to 1. In this case, range tells Python to start at 10, stop before reaching 0, and step down by minus 1 with each iteration. This allows the loop to count down from 10 to 1. Each time the for loop prints the current value of I, showing the countdown. Run the code and see for yourself. Let's break down the arguments we used in range. For start, which is where the loop begins, we use 10. In stop, which is where the loop stops, we used 0. But remember, Python stops one step before the stop value, so in this case, it stops before 0. And then step, that controls how much to increase or decrease each time the loop runs. Here, we're using minus 1 to count down by 1 with each iteration. You might have noticed that we use the letter I in both of our examples, but what exactly is I? In a for loop, I is just a variable name, short for iterator or index. that takes on the value of each number in the sequence generated by range. In our first example, I went from 0 to 4 because we used range 5. In the countdown example, I went from 10 to 1 because we used range 10, 0, minus 1. Do you remember when we iterated over the word Python? We used letter instead of I there, so we already had a more descriptive name for that variable. So each cycle of the loop, I, in that case letter, was a letter from our word. Each time the loop runs, Python assigns the next value in the sequence to I, and then the code inside the loop is executed. You don't have to use I, you can use any variable name you like we used letter in the Python word example. For instance, we could write. In this case, we've named our variable number instead of I. It works exactly the same, but sometimes choosing a more descriptive variable name makes your code easier to understand. However, you'll often see I used as a default variable in loop, especially when the variable name doesn't need to be descriptive for the task at hand. I stands for iterator, and it's a common shorthand. Now let's make our program a bit more interactive by using the input function to control how many times the loop runs. First, we prompt the user to enter a number. Do you remember how to do it? Create a variable and assign input to it. Just a quick reminder, we need the output of this input to be a number. Do you remember what we need to do in this case? That's right, wrap input with int, so we get an integer. Then we use the range function in our for loop to repeat the action as many times as the user requested. Here's an example. This integration between loops and other Python features like input makes your code dynamic and responsive to what the user wants. With just a few lines of code, you can create programs that react based on the user input. And it's also great for you to play around with different Python features. Join them together, make mistakes, and learn more about those mistakes. Remember, mistakes are the way to move. Each error helps you improve. Let's start by combining what we've already learned so far by using a for loop with a conditional statement. For example, let's say we want to print a message only when a number is even. We can write a for loop to iterate over the numbers from 1 to 10. Then, inside the loop, we'll use an if statement to check whether the number is even. If it is, we'll print a message. You can even give it a shot yourself. Pause the video here and try it out. Then, when you're ready, come back to see how I tackled it. If you'd rather follow along, let's dive in together. In this example, we use range 1 to 11 to loop through the numbers 1 to 10. Remember, in Python, the range function stops one number before the stop value, so range 1 to 11 means the loop will include numbers from 1 to 10, but stop before 11. We also explicitly start from 1, rather than omitting the start value, because if we only use range 11, Python will start the loop at 0 by default. Since we want to begin at 1, we need to specify 1 as the start value. Inside the loop, we use an if statement to check whether the current number, I, is even. To do this, we use the modulo operator. Do you know what it is? Don't worry, my math is also a little bit rusty. So let's go over it together. If you're already familiar with this, feel free to skip ahead. I'll add a timestamp below for where you can jump. The modulo operator gives us the reminder when one number is divided by another. For example, 4 modulo 2 equals 0 because 4 divided by 2 has no remainder. 5 modulo 2 equals 1 because 5 divided by 2 leaves a remainder of 1. Did you get the idea behind these examples? If not, don't worry. Some people are more comfortable with numbers while others connect better with real-life examples. So let me give you a real-life example. Imagine you have a cake and you cut this cake into 6 slices for 3 guests. If you divide the slices equally, each guest gets 2 slices. Simple enough, right? Now let's say you have 4 guests instead of 3. If you divide the cake among the 4 guests, each one will get 1 slice, and you'll have 2 slices left over. Those 2 leftover slices represent the remainder in mathematical terms. In regular division, if we divide 6 by 4, the answer is 1.5, since each guest will get 1.5 slices if we cut the leftovers into smaller pieces. But modulo is different. Instead of giving us fractions, it just gives us the whole number remainder. In this case, 6 modulo 4 equals 2, the remainder. Does this make it clearer? If not, that's totally fine. Everyone learns in a different way. Feel free to leave a comment and I'd be happy to explain it further, or if needed, I can make a shorter video just on this concept. What is important to know, for our example, is that when a number is divided evenly by 2, meaning the remainder is 0, we know that the number is even. So in our if statement, we check if I modulo 2 equals 0. If it is, that means the current number is even, and we print a message. This combination of loops and conditionals allow us to create more complex behavior, taking action only when a specific condition is met. It's a powerful way to make your code both flexible and efficient. Now, let's dive into while loops. These loops work a bit differently from for loops, so let's break it down. While loops keep running as long as a condition is true. Let's get back to a cake example, because I do love some cake. Think of it like checking if there's still cake left at a party. As long as there's cake left, you'll keep serving it to the guests. Once the cake runs out, you stop serving. This is a perfect real-world example of how a while loop works, continuing to perform an action as long as the condition, in this case having cake, is true. While loops are very similar to if statements, but with one key difference. Instead of checking a condition just once and moving on, while loops keep checking the condition and repeating the action until the condition changes. This makes while loops incredibly useful when you don't know how many times you'll need to repeat an action. Let's write a simple example. In this example, the loop runs while boolean value is true. Inside the loop, we print a message and then change boolean value to false, which stops the loop after just one iteration. Once the loop ends, Python moves on to the next statement, which prints the value is false. While loops are incredibly powerful, especially in situations like game development. Imagine a game that keeps running while your character has health. Once your health hits 0, the game loop ends and you get the infamous game over screen. I normally do a mistakes and tips section, and I will do in part 3, but I want to give special attention to this one mistake.
The infinite loop of death.
Okay, maybe that's a bit dramatic. It's really just called an infinite loop. This happens when the condition in the while loop never becomes false, meaning the loop keeps running forever. If your loop is stuck running indefinitely, it could slow down or even crash your program, especially if it's performing complex operations. For example, in the earlier example, I reassigned boolean value to false to stop the loop, but imagine I forgot to do that. The condition will stay true forever, causing the loop to run indefinitely. Let me quickly show you what that looks like, but please, don't try this yourself in the online editor we're using. We don't want to overload their servers. As you can see, the console kept printing the message over and over. Now imagine this was a more complex loop. It could crash your computer or use up too many system resources. So always be careful when writing while loops and make sure the condition will eventually become false. Now that we understand the basics of while loops, let's revisit our cake example. This time, it will be a little bit more complex. Imagine we are at a party, and we have 5 slices of cake and 3 guests. We want to serve 1 slice at a time, but we also want to check how many guests are left. We'll use a while loop to keep serving slices as long as both cake and guests remain. Once either the cake runs out, or there are no more guests, the loop will stop. Here's how it works. In this example, the while loop runs as long as both cake slices and guests are greater than 0. With each iteration, we serve a slice of cake, reducing cake slices by 1, and reduce the number of guests by 1. Once the cake is gone, or there are no more guests, the loop stops and we print a message, no more cake or guests left. This example shows how while loops can control multiple conditions and handle real-world scenarios with dynamic variables. Also, I want to quickly mention the syntax you saw, cake slices -1 and guests -1. For some of you this might have made perfect sense, but let's take a moment to break it down. What this is really doing is subtracting 1 from the current value of cake slices and reassigning that new value back to the same variable. It's the same as writing cake slices equal cake slices -1. Essentially, we're telling Python, take the old value of cake slices, subtract 1, and store the new value in the same variable. We can also do this with addition using cake slices plus equal 1, which will add 1 to the current value. These types of operators are called Python assignment operators, and they're really handy in loops to simplify code when updating variables. If you want to explore more of these operators, feel free to check out a comprehensive list on W3 Schools. As you practice with while loops, you'll begin to see how powerful they are, especially when combined with multiple conditions and variables. Can you see the similarities between conditional statements and while loops? They both guide the flow of the program based on a condition being true or false. Now that we've seen both while loops and for loops, let's compare the two. A for loop is typically used when you know in advance how many times you want to repeat an action. It iterates over a sequence like a range of numbers, a list, which is another data type we'll explore later, or a string. For loops are perfect for tasks where the number of iterations is fixed. On the other hand, a while loop is more flexible. It's used when you don't know exactly how many times an action will need to be repeated. The loops will keep running as long as a condition remains true. This makes it especially useful for scenarios where the stopping point depends on something that changes during the loop. In short, use a for loop when you have a known, fixed numbers of iterations, and use a while loop when the number of iterations depends on changing conditions. Let's put our knowledge into practice with a fun, simple project. How about a guessing game? We'll use a while loop to keep the game running until the player guesses the correct number, and a for loop to give them a set number of tries. This example shows you how versatile loops are and how they can interact within your programs. First, we need a secret number the player will try to guess. Let's set that to 5 for now. Next, we want the game to keep running until the player guesses the correct number, so we'll use a while loop. We'll start by setting a flag, game running. That controls the game flow. Inside the while loop, we'll begin a new round of the game. The player will get 3 attempts to guess the number. We'll print a message at the start of each new game to keep things interactive. For the guessing part, we'll use a for loop to give the player exactly 3 chances to guess the number. We can create a loop that runs 3 times, and inside this loop, we'll prompt the player to enter their guess. Once the player enters their guess, we'll check if it matches the secret number using an if statement. If they guess correctly, we'll congratulate them, stop the game by changing the game state, and break out of the loop, since they don't need more attempts. But if the guess is wrong, we'll tell them to try again, and the loop will continue. And the for loop finishes either because they guessed wrong 3 times, or broke out early by guessing correctly. We'll check if the game is still running. If it is, it means they've used all their attempts without guessing correctly, so we'll start a new round. Did you notice how we used break in the for loop to stop further guesses once the player guessed correctly? This is a handy way to exit the loop early, and we'll dive deeper into how break, continue, and pass work in the next section. Just like how we used if statements in our previous video to guide the flow of the program, now we're combining loops with conditionals to create a more interactive and engaging experience. Before we jump into common mistakes, let's quickly go over 3 key statements that control how your loops behave: break, continue, and pass. We've already seen one of these in action. Remember, in the guessing game, when the player guessed the correct number and we used break to stop the loop? Break is a powerful tool that lets us control exactly when we want a loop to end. As soon as the correct guess was made, break stepped in and ended the loop. No need to continue checking. That's the magic of break. It lets you stop the loop right when you need to. But 2 other statements can also help control loops: continue and pass. Let's start with continue. What if you want to skip over certain iterations but keep the loop running? Continue does exactly that. It skips the current iteration and moves to the next one. Check out this example. In this case, the loop ignores number 5, but continues printing the rest. It's like saying, I'm not interested in this one, let's skip ahead. Finally, there's pass. Sometimes you might not be ready to implement a part of your code just yet, but you need to structure to be there. Pass is a placeholder. It doesn't do anything, but it keeps the loop valid. Here's how you'd use it. Try removing pass and see what happens. Pass is great for those moments when you're still planning what the loop should do but want to keep everything running smoothly. So, to wrap this up, break lets you stop a loop, continue skips to the next iteration, and pass acts as a placeholder where you're not quite ready to add your logic. Now, let's talk about some common mistakes you might encounter when using loops. Loops are incredibly useful, but they also come with their own set of challenges. A common mistake, and one of the trickiest to spot, which we covered already, is creating an infinite loop by forgetting to update the condition, especially in while loops, where the logic isn't always as clear. Just like we discussed in the last video, keeping your conditions correct is essential, but there's more to watch out for. For instance, off by 1 errors are frequent in for loops when misinterpreting how ranges work. Remember, range 5 includes numbers from 0 to 4, but not 5. A small misunderstanding here can lead to subtle bugs, so always double check your boundaries. Another mistake is modifying the loop variable inside a for loop. This can lead to unexpected behavior, so it's generally best avoided. If you need to adjust variables inside the loop, a while loop might be more appropriate. In a for loop, modifying the loop variables doesn't affect the loop's progression. The loop will continue with the next value from the range sequence, regardless of any changes made to the loop variable inside the loop body. This means that the loop will not skip iterations based on modifications to the loop variable. It will still proceed through the sequences defined by range 5. The consequence of that is, while the values printed might change due to the modification, the number of iterations and the flow of the loop remain unaffected. In the given example, modifying I inside the loop doesn't alter the flow of the for loop itself or the number of iterations. The loop continues with the next value in the range sequence, leading to changes only in the values being printed. Even though it might seem that the loop should skip iterations, in reality the value of I is resetted in each iteration by the for loop, and the modifications made inside the loop do not persist beyond each iteration. In the while loop, the loop variable is controlled within the loop body and directly impacts the loop condition. This approach works as expected and allows you to modify the loop variable effectively. Speaking of which, choosing the right type of loop is key. Use for loops when you know the number of iterations ahead of time, and while loops when the number of iterations isn't clear or you want to control the loop based on a condition. Another subtle issue is overusing break statements. Placing too many or positioning them incorrectly can make your code harder to follow. Try to minimize the use of break or structure your loops so they're not needed at all. You might already know about using else with if statements, but did you know you can use else with both for and while loops as well? The else block in loops runs only if the loop completes normally without encountering a break statement. Here's an example using else in a for loop. In this case, the else block runs after the for loop finishes iterating over all the numbers from 0 to 4. If we had used the break statement to stop the loop early, the else block wouldn't have executed. You can also use else with while loops. Let's look at an example where the else block is triggered after the loop completes without a break. Here, the else block is executed after the while loop finishes normally, because the loop condition counter lesser than 5 becomes false without using a break. The loop runs until the condition is no longer true, and once it completes, the else block prints loop completed without a break. This feature can help make your code cleaner and more readable by handling what happens when loop finishes naturally. Finally, here are a few debugging tips to keep things smooth. Use print statements strategically to track variable values, and simplify complex conditions by breaking them down. This makes your loops easier to read and maintain. By keeping an eye on these common pitfalls, you'll make your loops more efficient and less error-prone. Alright, it's time to put what you've learned into practice with a quick quiz. I'm going to show you a few code snippets, and I want you to either predict the output or spot any potential errors. Question 1. Let's start simple. Take a look at this for loop. What will the output be? Is it A, B, C, or D? Question 2. Consider the following loop. What is the impact of modifying I inside the loop? Analyze the behavior and select the most accurate statement from the options below. Question 3. On to while loops. How many times do you think this loop will execute? Will it run 1 time, 2 times, 3 times, infinite times? Think about how the condition changes with each iteration. Question 4. Let's return to for loops. What will the output be for this loop, where we introduce a break statement? And finally, question 5. Here's a question about the continue statement. What happens in this loop? Choose the answers you think are correct, and let's see how well you understand loops. Share your responses in the comments below and let's discuss. This is a great way to test your knowledge and get feedback from others in real time. I'll reveal the correct answers in the next video, so stay tuned. And that is a wrap on our complete journey into loops in Python. Whether you're here for a refresher or experiencing this for the first time, I hope this long-form compilation gave you the clarity and depth you were looking for. By now, you've seen how for loops can handle repetitive tasks with precision, how while loops can adapt to ever-changing conditions, and how concepts like break, continue, and pass give you fine control over your code. We even brought it all together in real-world examples, tackled common mistakes, and tested your skills with quizzes. It's been a lot of ground to cover, but you stuck with it, and that's an amazing step forward in your Python journey. Now it's time to apply what you've learned, try building something new, explore, and don't shy away from challenges. Mistakes are your stepping stones to mastery, and every project, no matter how small, helps you grow. As always, I'd love to see what you created, so drop your thoughts in the comments below if you found this helpful. Don't forget to like, subscribe, and share it with others who might benefit. Keep coding, stay curious, and I'll see you in the next dimension.